Hello, everybody. Thank you for joining to this webinar. It's my pleasure to present in this webinar. And so I know Yasir from 2 years ago. I met Yasir in Hyderabad, and we met each other and we talked about the Bangladesh Oracle user group and so on. So after a year, Yasir successfully established the Bangladesh Oracle user group, and so congratulations with that as well. So there are a few guys who cannot hear any sound. So I think most of you can hear, right? Okay, great, wonderful. So so I decided, actually, I would like to visit Bangladesh one day. But before visiting Bangladesh, I wanted just to share my experience online with you guys. And so we decided with Yasser to provide a webinar to you guys. So that's why today we'll talk about, I will try to provide two different sessions, like a one session. It's about how to migrate your database to Oracle Cloud, and how to build a disaster recovery for your on-premise database in the Oracle Cloud. So now I will share my screen, and please let me know if you can see my screen. Let me just try to share it, the screen. Okay. So can you see my screen now? Okay, so I can proceed, right? Okay, let me know if you're stuck anywhere. Yasir, I'm checking my WhatsApp. If you have any problem regarding with the webinar or my speech or my screen, just let me know on my WhatsApp, okay? Because I will, or just you can just talk, okay? No problem. Okay, so in this session, I will talk about 8 ways to move your database to Oracle Cloud. So first of all, for those of you who don't know me, I'm from Azerbaijan, Baku. My country located in Eastern Europe and is bounded by the Caspian Sea in Russia and Iran and Turkey. So I'm working as a database team manager at Azercell Telecom. I'm 2-time Oracle Certified Master and ACE Director. I also authored 2 books. The first one was about RMAN backup and recovery, and the last one is about Oracle Certified Master Exam Guide. I'm also blogging at kamranaagayev.com, and 5 or 6 years ago, we also established Azerbaijan Oracle user group here in my country. So if you are Oracle Certified Professional already and want to go to Oracle Certified Master Exam, this book is for you guys. So go to ocmguide.com and download the PDF that contains a few chapters of this book, and start preparing for the OCM exam. Okay, whenever I deliver this presentation, most of the time I make a survey in the room, and I ask the visitors how many of you already migrated on-premise database to Oracle Cloud. And it's really interesting for me, what was the size of the migrated databases, and the most interesting part is how much downtime did you have during the migration, because the migration, the database size can be huge, and you might take few hours for downtime, or minutes, or seconds, or no downtime. I'm sorry. So in this session, we'll cover 8 ways to migrate your on-premise database to Oracle Cloud. I will talk about how to migrate database using Data Bomb, how to migrate database using transport tablespace option, and how to use the transportable tablespace migration with incremental backups in order to have less downtime, how to duplicate database to Oracle Cloud, how to perform the standby database failover, how to convert from the file system to ASM, from the zero downtime migration, and convert your single instance on-premise to rack in the cloud. Excuse me. So first of all, in order to start working with Oracle Cloud, you have to go to cloud.oracle.com and get a free service. Just log in. Subscribe to Oracle Cloud Service and get your free account. You will be provided with free $300 US free account, and just play with Oracle Cloud Services. So first of all, we have to create a database service, and we can choose the software release, software edition, and database type. So here we choose Oracle 12c Release 2 and Enterprise Edition. And then before moving to the next step, we have to generate the public and the private keys in order to be able to connect to the Oracle database service machine. So I use PATE key generator, and I created public and private keys, and save this public key and the private key, and then I provide this public key when I create database service, and then I click next, and in a few minutes my database in the cloud is ready, and I will be provided, or you will be provided, with a public IP. Here's my public IP, and I use any SSH client and log in to your database service machine. If you don't provide the private key during the connection, you will not be able to log into your database machine in the cloud. So you have to provide the private key. So during the installation, during the database service creation, you provided the public key, right? And during the connection, you have to provide a private key. So you provide a private key, and here it is. You are connected to your Oracle database machine. So first of all, I will talk about migrating database using data pump. So if the database size is small, and if you can easily have a downtime, or if you need to move all the specific schemas, you can go with a data pump. It's the best tool, but you have to know that you will get the downtime. So I will not talk about how to export the database and how to import it, because I'm pretty sure you have already done it hundreds of times. But in this session, I want to show you a new feature that comes with Oracle 12c, which is full transport table export and import. So in Oracle 10G, when we were transporting the database or performing the export, we were not able to show the transport table option along with the full option, with full parameter, because transport table parameter was not available in Oracle 10G. In Oracle 11G, transport table parameter was introduced, but it was not possible to use the transport table parameter along with the full parameter in the same export. Or you will get an error saying consistent arguments. You cannot use the transport table with the full jobs. But in Oracle 12c, you can perform the data pump export job. You can perform the export of a database using the transport table option and providing the full parameter as well. So in this case, what data pump will do is it will take the metadata. It will create a dump file of the meta that contains the metadata of the whole database, but will not dump the data. To provide a list of data files that have to be moved to the destination database, to the cloud machine, or to anywhere. So we have to put the table spaces in read-only mode, and when we run this command, the metadata of the whole database of the all objects will be exported to this dump file, and export will be finished. And then you will be asked to move. You will be provided with a list of the data files that should be moved to the destination and imported. So let me show how it works. Imagine that we have three table spaces, and each table in any table space. So first of all, you have to put all table spaces in read-only mode. If you don't put your table space in read-only mode and try to use transport table option, the export process will fail, and you will get the following errors, like saying table space blah 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 is not read-only. So you put the table space in read-only mode and run this command, and you will get this output. Even if your database is 1 terabyte, it will take a few minutes to get to finish this the data pump job, because it will only take metadata of your database to the dump file and will provide you a list of the data files that should be moved and plugged into the remote database. So there's a problem with the user table space, because whenever you want to move the database from one database to another, you create this target database as well, right? And it already contains the user table space, and you have created. Your source database contains user table space, and your target database contains user table space. So whenever you will try to import it, you will get errors saying table space users already exist. If you try to exclude the table space during the import process, you will fail, because the data file, the dump file, contains information about 4 data files or 4 table spaces, as well as the user's table space, but you exclude it. So you will get error saying the wrong number of transport data files specified. It was expecting 4 data files, and you provided only 3 because you excluded the user's table space. So it's better to perform the export. To exclude the table space during the export. So you run the export command, you provide a transport table equals always full equals y, and you exclude the table space during the export. And during the import, you provide only 3 data files. And after that, if you check the DBA segments view, you will see that all table spaces were created, and all segments, objects are created under those table spaces. So the second option is to use the transport table space and transport table database option. So before using transport table space or database option, you have to check the Indian format. So check the Indian format, and we check the Indian format by querying video transport table platform or video database use. So next, we have to check if the table space is self-contained, because you might have a partition table, where half the partitions might reside on one table space and another half might reside on a different table space. So if in this case, if you try to export or to move only the first table space, you will fail, because the half part of the second part of the table resides on the different table space that you are not moving. So in this case, you have to combine, or you have to move all partitions from one table space to another table space and move only that table space. So in this case, we run table space self-contained check and query transport set violations view. If the output is no row selected, if it didn't if it didn't return any output, so everything is fine. We can go on. We put the table space in read-only mode. We generate the metadata export of a transport table space by running XTP command and provide and give list of the table spaces. And next we copy data files and export down file to the cloud host, take a source table space from the read-only mode. And then, so if you are moving the table spaces from one platform to different platform, we have to convert the data file. So we run the convert data file command. We provide, we give the source and the target platform name, and after that we import the data files. We import the database to the target to the cloud machine. So the cloud machine comes with Oracle Linux operating system installed. So if you use a different operating system, you have to perform the conversion. Let me check if everything is okay with okay, everything is okay with here. Okay, go on. So there are if you use the transportable table space option, there are some best practices that I would like to share with you guys. First of all, make sure to perform data file conversion on the system with beta IO. So imagine that you are moving your on-premise database to Oracle Cloud, and your on-premise database is running on HP UX, and you want to move it to Oracle Cloud, which runs on Oracle Linux. So you have to perform the conversion, right? In this case, it's better to perform the conversion in the beta hardware. So if your on-premise database, if the hardware of your on-premise database is slow, so it's better to perform the conversion in the cloud machine. So if you're running 8 gigabytes RAM, if you have an 8 gigabyte RAM or one CPU or two CPUs on your on-premise database, it would be better to move all your data files to Oracle Cloud Machine, add much more, as more CPU and RAM as you want, perform the conversion, and then release the memory and CPU. So run data file conversion in parallel, even if it would be better to run to use all rack nodes if you are running the rack environment. So it would be better to perform data file transfer and data file conversion simultaneously. So if you have 100 data files, move your first 30 or 40 data files to cloud machine, start a conversion in the cloud machine, and then perform the data file transfer in the same time simultaneously. It could be better to set network parameters for optimal transfer capacity. I mean, talk to your network team on this, resize data files to the high watermark before transfer, because you might have huge data files. I mean, the DBA of the team, any DBA of the team might create huge data files, but the data files might contain not much data. So you might have 32 gigabyte of data file, which contains only 1 gigabyte of data. It's better to resize the data file to the high watermark before the transfer. So I think that there is somebody who didn't mute the microphone. Okay, it's okay now. And it will be better to compress data files before the transfer. So cross-platform database conversion. So you need to have the same indent format in order to use cross-platform database conversion. So in this case, you have to put the whole database, the entire database in read-only mode, and it means the downtime. Then you run check_db function, and after that you run the convert database command, and it will create a script, and then you move all your data files to the remote, the cloud machine, run the script, and it will duplicate, it will create a new database. It will create a database based on all your data files and using the transport script here. So it means that you using cross-platform database feature, you cannot move database from different platforms from different Indian format to a different Indian format. So you can use convert database to convert Linux Windows database to the Linux database, but you cannot convert HPUX to Linux or Solaris to Linux as well. So next, cross-platform transportability is based with incremental backups. So far we have shown two different ways to move your database to the Oracle Cloud machine, but in both cases we realized that we saw that we have to get downtime in order to move database or data files or table spaces. But I mean, if you are running with a business critical database, a mission critical database, having such huge downtime might not be the case. So in order to avoid downtime, it's better to use transportable tablespace with incremental backups, and I will show how it works. So imagine that we have an HPUX database, and we want to move HPUX database to the Oracle Cloud that is running on the Oracle Cloud machine that's running Oracle Enterprise Linux operating system. And we want to get a database size is 100 terabytes, and we want to get a few minutes of downtime. So what we have to do is we have to first step is to take full incremental level 0 backup. We take full incremental level 0 backup of the specific table spaces or all table spaces and transfer it to the cloud machine and restore it using RMAN. Okay, we have taken backup of all table spaces in HPUX. We transfer to the cloud machine and restore it using RMAN. And then we convert it as well. And then we take another incremental level 1 backup, which contains only changes, which will take only changed blocks that were changed after the first incremental level 0 backup. We transfer to the cloud machine and recover it using RMAN. Of course, we have to convert the backup files and then recover it using RMAN. So up to that point, we don't have any downtime, right? And we repeat the last step. We repeat this step as much as we can in order to decrease the downtime, time of the downtime. And at the end, we put the tablespace into read-only mode. We take the last incremental level 1 backup. We export the metadata of tablespace using the dump file, using the data pump. We transfer backup and dump file to the cloud machine, recover the backup, and import that dump file. So if you want to get more information on this feature, you can check the mentioned MetaLink notes. We have in my company we have moved 50 terabytes of database from HPUX to Oracle Linux operating system, and we had only a few minutes of downtime. And these steps only requires downtime, which will take only a few minutes. So here how it works. Imagine we created table space in HPUX. We create table on that table space, and we take an incremental level 0 backup, and we perform change on the table, and we take another incremental level 1 backup. We move the backups to the cloud machine, and we restore it. So we have to provide. We can convert. We can convert the database while backing up the database. We can convert the data files while backing up the data files, or we can convert data files while restoring. So here we have powerful hardware in our cloud machine, and we decided to perform the conversion during the restore. So we run a restore from platform. We provide the platform name, and it restores and converts the data files on the fly. We run recover from platform command as well. So it will apply the incremental level 1 backup. It will restore the data files and converts data files and applies those changes to the restored data files. And after that, we repeat the last step as much as we can. And at the end, we put the tablespace in read-only mode in the source database, take the last incremental level 1 backup. It will take a few minutes, 1 or 2 minutes, because only few blocks were changed up to that point. And then we run export XPP data pump to provide the list of the table spaces to get the metadata of the table space, move the lost incremental backup and dump file to the cloud machine, put the table space in read-only mode, recover the table space, and import the metadata and put the table spaces in read-write mode. That's how it works. So you might have a huge database. I mean, you might have the database size might be hundreds of terabytes, and you might have thousands of data files. And dealing with thousands of the data files might be you can use the built-in. I mean, not a built-in, but you can use the tool that is provided by Oracle, which is called RMAN XTT Convert. The latest version, I think it's version 3. So this tool is written in Perl, and it automates the whole process. So you can go to the mentioned method and download the conversion tool. So using this conversion tool, you can easily take a backup of your of all your table spaces by running only one command. You can run only XTT driver restore command and restore, perform the restore. All what you have to do is to provide a list of the table spaces as a parameter that you are going to move. And this tool will make your life easy. So another new feature that comes in Oracle 12c regarding cross-platform database transfer is performing the cross-platform database transport to different Indian formats with RMAN backup sets. So let me show what does it mean. I mean, so imagine that you have the Solaris operating system and you want to move database from Solaris to Oracle Linux or Oracle Cloud Machine. So again, you put a table space in read-only mode. And to take the table space backup and metadata dump file with a single command. So you take a backup of the database and you take the metadata of the database from RMAN. You don't run any data pump command. Then you transfer the backup set to destination server and restore an RMAN and data pump backup sets using a single command again. So here how it works. Again, we put this in read-only mode. I mean, this is the last step. So we take a backup of the table space. We convert the backup directly from the Solaris machine. We provide a format, and here we provide data pump format. So it will take the metadata of this table space, dump of the metadata of this table space with a single command. And when we restore it, we restore the backup from the backup set, and we restore the dump file from the dump file backup set, right? And so the first inconsistent backup is level 0 incremental backup. So imagine that we didn't put the table space in read-only mode, and we run this command while the database is online and while the users are changing the database. So subsequently, you can create multiple cross-platform level 1 incremental backup. But in this case, you have to provide a low inconsistent parameter during the backup. So you backup the database, you back up the table space, backup for transport, allow inconsistent incremental level 0 table space. Means that I'm backing up the table space, allow me to take an inconsistent incremental level 0 backup. I will put the table space in read-only mode at the end of the process. So allow me. So Oracle will. So this command will run successfully, and it will take the level 0 backup. And next you have to restore data file or table space, the cloud machine, and then you run the same command again, but take level 1 backup and recover it. And at the end, you put the table space in read-only mode and take the loss incremental level 1 backup with along the data file. Remove the incremental backup and down file to cloud machine and restore it. So you restore the dump file, restore the dump file here, restore the foreign data file, and import the metadata, and that's it. The next is duplicating the on-premise database to the Oracle Cloud. So how it works? You can perform a disaster recovery of on-premise database to Oracle Cloud using backups transferred to the cloud machine, or using backups stored in Oracle Public Cloud storage. Or you can perform active database duplication of on-premise database to Oracle Cloud. I have performed all these steps, but believe me, it all depends on your network bandwidth if you want to go to the active database duplication of the on-premise database to the Oracle Cloud machine. But let me show how we can use Oracle Public Cloud Storage in the next slides. So the first option is the easiest option. You take a full backup of the database, of the on-premise database. You copy backups to Oracle Cloud Server. You configure the network parameters, and you start the database in no mount mode and run duplicate touch database command and just duplicate the Oracle. I mean, you connect the on-premise database and you connect to the auxiliary instance, which is the Cloud DB, and duplicate touch database command. But this is the easiest way. If you want to, but the better, if you don't have enough space to store your backup in the on-premise database as well as in the Oracle Cloud machine, it's better to use Oracle Public Cloud Storage. So if you get the Oracle database service from the cloud, you can also get Oracle Database Cloud, Oracle Public Cloud Storage as well. So in order to use Oracle Public Cloud Storage, in order to back up your database to Oracle Public Cloud Storage, you have to use Oracle Database Cloud Backup module. So you download it from the mentioned link. I mean, just go to Google and type Oracle Database Cloud Backup module. It will provide you this link, and then you extract the zip file and install it. So before the installation, make sure to create valid and library file folders and run Java. And when you download and extract a file, you will get OPC install jar file. So it's Oracle Public Cloud install jar file, and you provide a service name. You provide the OPC ID, which is Oracle Public Cloud ID. You provide your public cloud password and hit enter. And then it will create the valid files, put the library file in the home Oracle lib folder, and put the valid files in this folder, and it's ready. And it will be provided, and you will be provided with the OPC database name.org file. It's Oracle Public Cloud. It's Oracle Public Cloud Storage configuration file. So, and where we're going to use this public cloud file. Okay, now we configure configure the channel. I mean, we don't configure the channel to take the backups at disks, but we configure the channel to use SPT library, and we run configure channel device type SPT tape, and as a parameter, we provide the library, which is downloaded from the Oracle libopc, which is library Oracle public cloud, and as an OPC file, a public cloud storage configuration file, we provide the public cloud configuration file that was created during the installation. So we can configure the compression, we can configure default device type to SPT tape, and etc. And that's it. We run the backup database plus archive log command, and it will take a backup of your database to the Oracle public cloud storage. So next, you create a database service in Oracle public cloud service, database service, and you allocate the same channel to your same public cloud storage and restore the database. So the admin will allocate channel to Oracle public cloud storage using your public cloud storage configuration file, which is provided here as a parameter, and it will restore and record database and open database. So if you don't have enough space to store your backup files and perform the migration, you can easily use Oracle public cloud storage. Excuse me. And you can also run duplicate project database command as well. So when moving to Oracle public cloud storage, when moving to Oracle the cloud database, your on-premise database to Oracle Cloud, one of the options is to create a standby database and perform the failover. So why on earth we have to use the standby option when we can easily duplicate or restore and recover database? So imagine you are running the database on your on-premise, and I mean, a lot of users, hundreds of thousands of users are connected to your on-premise database, and in some point of time you decide to move to Oracle Cloud and move your database to Oracle Cloud successfully, and relocate, or not relocate, but change the TNS entry in your client and move all your clients to use Oracle Public Cloud database. But for any reason, if they fail to connect, or because of the network bandwidth, or for any reason, if they will not be able to use the database in the Oracle Cloud as it is, as it was on premise. So it's a big problem. You have to go back as soon as possible. So in this case, it would be better to create a standby database in Oracle Cloud, perform the switch over to the Oracle Cloud machine, and start using it. So if you have any problem in the network bandwidth, or you have any different kind of a problem in that cloud service, you have to be able to go back to your on-premise database when you realize that you cannot go on live anymore with Oracle Cloud Machine. So you perform another switchover back to your on-premise database, and that's it. So in this slides, creating standby database is the same as duplicating database or just restoring and recovering it. So I wanted just to show how we can use server control to if we are going to take the backup of rack database in the on-prem. So make sure to use all nodes when opening our channels in your during the backup. So we create a service and we provide 2 nodes in that for that service, and we start that service. And when you connect to RMAN, make sure to use the service instead of using the database name. Or the node name, or one node. Don't connect to the one node. Connect to all nodes. Open as much session as you can, as much channel as you can, and use all the resources of your RAG database. Add the standby log files and duplicate target database for standby from active database. So you create your standby database in Oracle Cloud by connecting to the to all nodes in the RAG environment of your on-premise database and duplicate it, and that's it. So if the standby database version is at 12.1 or higher, you make sure to copy the password file of the ASM as well. Create a standby SP file in ASM, and that's it. And in the Oracle Cloud machine, if you want to run the RAG database, use server control, add instance to add more instances to the database as much as you can, and perform the switchover and open the database. So if you hit any failure, any bug, any problem, you will be able to switch over back to your on-premise database. So next is ASM to non-ASM conversion. So whenever you create an Oracle RAG database in Oracle Cloud Service, you are provided to create 2-node cluster. You can also use RAG command line interface utility for backup and recovery, or patch and fly, or any administrative tasks in using the command line. And the database file storage is ASM on ACFS on ASM. So if you are running in a file system and you are running on ASM and want to convert it to the file system, so if you take an R1 backup, move it to the cloud machine, restore it, it will try to find these group names in the cloud machine. So it's better to run set new name for data file during the restore, or just rename the data files after the restore. Before the restoration. Or you can generate a rename script for an on-premise database and run it in the cloud machine. Restore the RMAN backup to the cloud machine and switch data file all in order to rename the data file names in the control file as well. Core database and open database in result logs mode. Next and the best option in order to move your on-premise database to Oracle Cloud is to use the Golden Gate certification. It's a little bit hard to configure the Golden Gate certification, but it's very good tool in terms of the downtime, because it's the best option if you want to move your database with minimal downtime, near zero downtime, or no downtime. So Golden Gate is an extraction and verification tool from one database to another, from any database to Oracle, or from Oracle to any database. It can be used in unidirectional configuration. You have a database and you want to move, you want to replicate the database, or it can be used bidirectional, like say to keep both databases in sync, or peer-to-peer, or broadcast configuration. You might have one data warehouse, and you might create replicated databases to replicate part of the data to different databases, or you can build up a consolidation structure or the configuration. You might have one data warehouse, and you might have different sources where you can build up and configure Golden Gate to move some of the data, to consolidate data in one big data warehouse. Or you can use cascading configuration as well. Cascade data from one database to the another, and from the second database to 3 or 5 or more databases. But we can use Golden Gate. In order to move, we can use Golden Gate for the migration purposes as well. So download and extract a zip file, create a subdirectories, and execute the following scripts to create the required objects for the Golden Gate, and add and extract, provide the data, provide the schema names, or you can replicate the whole database, or you can replicate part of the database, specific tables or schemas. And so here it works. I mean, we have an old production, we have a production database, and it's online and up and running, and we extract this information. We create an extract, and we perform an initial load. It can be performed using data pump or RMAN. So there is no limitation in terms of the Indian format or in terms of the platform. You can as long as you can use a data pump, you can perform the initial load from using the data pump from any platform. So we perform the initial load. Imagine it's SolarEdge operating system, and we perform the initial load using data pump or RMAN or cloud machine. It takes a long time, and during that time, the extract process will collect all changes, the trail, and then pump all changes over the network. The trail that resides in instance on-premise database to 2-node rack in Oracle Cloud. So you can create a rack database service in Oracle Cloud. So when creating a service in Oracle Cloud, when you're creating a database service, choose the database clustering with rack. But before choosing it, in order to make this database type is available, you have to choose Enterprise Edition Extreme Performance and choose database clustering with rack. It will create a 2-node rack database. So back up your database, on-premise database, and using RMAN and cloud machine. If the file names are different, you set new name and duplicate type database. So I mean, whenever you create a database service here, whenever you create a database service, it will create 2-node rack database, and it will create an initial database. So you have to drop that database. You drop the database because it's empty. You take your backup of your production database and move it to the first node. And after moving it to the first node, you have to convert the database to the rack database, right? In order to convert the database to a single node database to a rack database, you have to change parameters like instance number, thread number. You have to create a new under table space for the second instance. You have to add the new log files to the second group, second thread, and enable it. You have to enable cluster database parameter, and that's it. And at the end, you have to add the database information to the OCR in the Oracle Cloud Machine by running server control add database and add instance commands. And at the end, server control status database, check the server control status database command, and you see that both your nodes are up and running. So final approach to on-premise migration to Oracle Cloud. So what is the final approach? If you want to use, if you're during the migration, it doesn't require any downtime. I mean, if it requires a downtime, if you can handle the downtime, if the database size is small, and so no extra downtime is required for the upgrade as well, go with the data pump. The database size is small, and if you can handle the downtime, go with the data pump, because it is platform and version independence. But if you cannot get the downtime, I mean, the transport table space option is better than the data pump, but it requires part of the downtime, and platform and version must be the same. But the best option, and the transportable tables and data pump, the better option is to go with incremental updated backups. So it requires a minimal downtime, and you don't move your old database, you move on the specific table spaces. Yes, it requires extra administration skills, but it's, I mean, you will be able to convert a huge database in a few minutes to the with few minutes downtime to the cloud machine. You can use duplicate database if the ending formats are same, or you can go with a data guard, use restore and recover in the cloud machine. Near zero downtime. So, but it requires a lot of extra administration skills. So, thank you for the first session. If it's okay, we have another session as well where I will talk about how to create a standby database and how to enable some security parameters in the Oracle Cloud Machine. If it's okay, we can move to the second session. Is it okay so far? So, in this session, I would like to talk about how to create, configure, and manage disaster recovery in Oracle Cloud for on-premise database. I will skip these slides. So, when we are talking about when we are talking about the standby database, about building disaster recovery in Oracle Cloud or in general, I'm really interested how many of you had failure with production database that has not disaster recovery. Whenever I deliver this presentation, I saw a lot of hands. So how many of you still running mission critical database without standby database? I know a lot of you running still mission critical database without standby database, and it's really bad. And most of you guys, or most of us, as well as me, placed standby database in the same data center with a production database, which is not good design. So in this session, I will give a brief introduction to Data Guard in Oracle Cloud. I will talk about security requirements, how to deploy disaster recovery to the cloud, how to perform the encryption, and how to create a standby database and manage it in the Oracle Cloud. So first of all, let's assume that we have a control file and we lost the control file. So how do we have to make sure that that we can keep the database online if we lost the control file? Yes, the answer is correct. We have to multiplex the control file. And what happens if the multiplexed control file fails as well? So we put it in one disk group and the whole disk group fails with all of disks. Okay, the answer is we can create the normal redundancy disk group and put with two failure groups, two or more failure groups, and put our control files in the second disk group as well. So what happens if that disk group fails as well? So, okay, we have an answer. We create a data guard, but in the same data center. So what happens if there's a fire, or and after the fire, you enter your server room and you see your production database with along your standby database standing in like this. So what if there's an earthquake in your country or in your city, and you end up with this kind of image? Or what about if there's a flood in your country and you entered your data center swimming? So it can happen, and if it's not a good idea to put your data guard in the same data center, because whenever your data center fails, you will get a lot of phone calls from annoying users telling that they are not able to establish database connection. So actually, there are two options for disaster recovery to the cloud using Oracle Database Cloud Services. The first one is Data Guard utilizing Enterprise Edition or Enterprise Edition service or high performance service. So actually, disaster recovery in Oracle Cloud provides the following capabilities. You can able to monitor the standby database. You can able to perform the switchover or failover the on-premise database to the outage actually standby database and convert it back to the synchronized standby mode by simple clicks. Or you can build development test environment based on the standby database, or offload the read-only production workloads to the Oracle Cloud, to the cloud, the standby database running in the cloud, or offloading back up to the cloud. Or, I mean, you can put your own production database to the Oracle Cloud and create a standby database in the cloud as well. Or you can have your production database on-premise and create a standby database in Oracle Cloud and offload read-only production workflows to the cloud. So in terms of the service level requirements, your database should be available. I mean, recovery time objective, it describes the maximum acceptable downtime should an outage occur. So whenever you build a standby database, you have to check these service level requirements, availability, how much time it take for the downtime, how much time you can afford the downtime, and data protection, recovery point objective, which describes the maximum amount of data loss that can be tolerated, how much data you can lose. So answer is no data. And the performance, I mean, after the failover or after the switchover, database response time may be slower because create a standby database with minimal hardware resources, and you perform the switchover or failover to that hardware, and database response time will be slower than the previous one. All of this should be taken into account. So putting your database in Oracle Cloud is scary. Why? Because of the security issues. So you put your database different machine, different country. So you have to make sure that it is encrypted, and the network is encrypted, and the data files and database is encrypted itself. So in this session, we'll talk about how to configure the network, how to create a database, and how to encrypt the database, and how to perform the switchover and failover. So we have already talked about how to create database service. Go to cloud.oracle.com and create a new service. So here we can, if you want to create a new database with its standby database, choose single instance with data guard standby. So it will provide you with two different machines with two different IP addresses. The first one will be your production database. The second one will be totally synchronized standby database. And you will be able to perform switchover and failover anytime by single clicks. Okay, and here you have two options: the high availability and disaster recovery. Okay. So configuring network. I mean, you have to secure the port connectivity, and you have to create security rules and make sure the Oracle network encryption is configured, and that's it. So by default, the listener port 1521 port is disabled. So remove that default listener and create a security list and add on-premise IP list. So only these IP addresses can connect to your standby database. Create a security IP list and provide on-premise IP addresses to that security list. And then create a new standby listener or a new listener and provide the random or specific port number for the listener port. And then provide the security IP lists. So only these IP addresses written listed in the security IP lists, DR to cloud, can do an SSH. So TDE tablespace encryption has to be configured in your both in your production and standby database. So if you cannot use Oracle Data Pump in order to load the database, to load the information from production database to standby database, so you have to perform extra steps in order to enable the tablespace encryption. So here are the steps. So first of all, you have to verify that the data card configuration is healthy and correct. Then you have to create an encryption valid and set the master key, copy the valid files to all nodes, and then place the standby database in a mounted state, and you have to stop the recovery. And on the standby, you will start encrypting. Let me show the screen. Let me show the pointer. So on the standby database, you will start encrypting the data files in place or in parallel, and then restart the redo. And after that, perform the switchover and repeat the steps on the new standby database as well. And after that, perform another switchover back to the previous standby database, and in that way, you will encrypt your on-premise database as well as your standby database. So here are the steps. First of all, create an encryption valid. Disconnect.org file provide the directory for your valid files. And then run alter system set encryption key identified by password in order to set the master encryption key. And open it, providing the password file. It would be better to create auto login valid because you will not be able to start a database without providing the password file. So it's when you shut down the database. So it's better to create an auto login valid file. Stop and start a database in mount mode in the standby database. Now database the standby database is started in the mount mode, and we stop the log shipment. We stop the log shipment. We get the list of the data files from the video log data file and create the bunch of altered database data file blah 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 encrypt command based on all data files that we have. And after that, we run this command and we convert all data files by running altered database data file encrypt. So we convert data files. We can convert data files in parallel. And after that, after converting data files in the standby database, we use DB verify utility to confirm that usage blocks are encrypted. So here it is. Okay, it's encrypted. So we use DB verify utility to make sure that the data files are encrypted. After that, we start the log shipment and perform the switchover. So now we perform the switchover. Now the production database running in the Oracle Cloud, which is encrypted, and on-premise database is now a standby database, and we have to enable TDE on that database as well. So we perform the same steps. So how to create a standby database? We have already talked about how to create a standby database in Oracle for your on-premise database in the Oracle Cloud. So first of all, configure the prompt SSH in both on-premise and Oracle Cloud hosts. So if you create a new database in Oracle Cloud Machine, you have to, if you create a new database service, it comes with already running a database. So you have to drop that database using drop database command or dbc utility, etc. So next, you have to configure the Oracle network encryption by configuring encryption server, encryption type server, encryption client, encryption types client parameters. Okay. So you can use both, or you can use any of these encryption algorithms for network encryption. And after that, we start the instance in no mount mode. So we can configure TD8 before proceeding the creation process as well. And here are the steps. So here we create encryption valid, create a password, open the wallet, create auto login, and copy the generated key files to standby and primary hosts. It should reside on both hosts. Or we can create standby database using arm and duplicate command. I mean, we configure the channel, we connect to on-premise, we connect to Oracle Cloud Machine, and we run duplicate touch database for standby from active database. So start copying data files from the on-premise database to our cloud machine and create a standby database on fly. And you can provide log file name convert, DB file name convert parameters as well for providing for creating read log files and data files in the cloud machine. Or you can create standby database using database backup cloud service as well. So again, we download the OPC installed jar file, we configure the channel. We have talked about this in my previous presentation. We enable the encryption. We install the cloud backup tool to the Oracle Cloud Machine as well. So we install it to the Oracle Cloud Machine. We copy the OPC prod, OPC Oracle Public Cloud configuration file to the Oracle Cloud Machine as well, and restore the database. Here the restore script. We restore database, we recover database, and we put it in the mount mode. So how to manage data guard in Oracle Cloud? Actually, Oracle provides several, health check tools that can be downloaded from Oracle Metalink support. It is OraCheck or ExitCheck. If you are running Exadata, it's ExitCheck. If you are running non-Exadata, it's OraCheck, which is suitable for database cloud service as well. So we run OraCheck tool, and it will perform the health check of our standby database. So it's not enough, actually. Yeah, it's better to offload some read-only workload to the standby database as well, in order to make sure that the standby database is ready for the production switchover, right? So it's also better to periodically place standby database in read-write mode to make sure that it's ready for the production switchover, or takes the standby snapshots for patch installations, or upgrades, or performing or creating a test and development databases in order to make sure the standby database works. So if you use Data Guard Manager from 12c, you can use validate database standby. So validate database command validates that the standby database, that you can perform the switch over to the standby database. Again, it's better to convert standby database into snapshot standby, or perform any required SQL installations to patch on the snapshot standby. So standby is there, and you have to use it. Usually use it in order for the testing purpose, in order to make sure that it's ready for the production switchover. Or you can also use Oracle RAS tool, replication testing tool, to make sure that the standby database is ready for the production load, and that's it. So here, how you can perform the switchover and perform the switchover back. And you can run validate database command. And here, this is the output you will get from the validate database command. It's ready for switchover, yes. So this feature comes with Oracle 12c. Perform the failover and perform the switchover and reinstate database from the failover. And at the end, you can also use DBAA as CLIs, data guard utility. I mean, it's not data guard, it's actually database cloud service, cloud service utility. And by providing data guard parameter, you can get its status, you can perform the switchover from the command line. You can perform the failover and reinstate the database, standby database as well. Okay, guys, this is what I have for you today. Please let me know if you have any question regarding the sessions.
Yes, it's my pleasure again. It's my pleasure to be part of it, to be part of, to help you guys to somehow grow as a Bangladesh Oracle user group. It's my pleasure, and I hope that in the future I will be visiting your country as well, and to meet all of you in person, inshallah.